Go!
Hello everyone, welcome to Practical GCP. So today I would like to talk about another introduction type session for Cloud Composer. So Cloud Composer is a service that's run Apache Airflow on Google Cloud. So the full of packed contents today. So we'll start with what is Cloud Composer and run into a simplified architecture, right? I don't want to go too much into the detail because it's important to understand kind of from a high level what it actually does, how it kind of things interact with each other. And I'll talk about web server and security, running into the command line tools that you can use on the cluster itself via the G-Cloud SDK. One of the very key features on Kubernetes executors, how you run customized workload. The two other areas, which is VPC native and private IP cluster, is very important to run the cluster securely, and also connecting to your on-prem network. CloudNet is one of these things that when you try to access the internet from the Composer cluster itself, you don't want to use public IP. Is kind of one of these things you can use to connect to your cluster to access other services on the internet. So finally, I'll talk about the difference between Composer 1 and Composer 2. Composer is something being made available from, I think it was beginning of this year or kind of to end of last year. Yeah, it's very, very amazing progress that the Composer team has made. And finally, I just want to do a quick summary of the talk I will be doing today. Okay, let's crack on. So first of all, what is Cloud Composer? Right, it's just a very simple diagram. To understand Cloud Composer, you should know what is Airflow first, right? And then what Airflow is designed to do. So this session is not designed to cover Apache Airflow, but I will give you a very quick kind of run through what usually people talk about Airflow, what it does, and the key features of what Airflow offers, right? So Airflow is a orchestrator. So what that means is you basically have a lot of these tasks, right? You put them together and you run them in the right order with very complex dependencies. And in order to manage those very complex dependencies, you need something like a directed graph. That's what DAG is. So DAG stands for directed acyclic graph. So acyclic means it travels in one direction, right? It doesn't go backwards. And there's a very important reason for that, because especially in data engineering or in data movements, right? When you move data, when you transform data, when you apply logic to data, you do not want to go backwards, right? If you go backwards, you end up with a circle. If you have a circle, then what happens is you no longer know what the source of truth is anymore, right? So you had some source, you transformed it, you go back and modify the source. How do you solve that problem, right? That's why it's directed acyclic graphs and graphs with no circles, right? That's what Airflow does in a nutshell. So this green box is Airflow itself, but to run Airflow without any kind of other wrappers or without a kind of the like engineering team that knows the DevOps best practices, knows the security, knows all the sort of other things around it, you can't really run it well properly, right? So this is where Cloud Composer comes in. It wraps around Airflow to look after the CPU side of things, the RAM side of things, the cluster management, and the security for you, right, on your behalf. So you just have to create it and run it in a nutshell. So that's kind of what Cloud Composer is, and it's a Google Cloud service that offers you to basically delegate, in my opinion, I think it's about probably 90 to 95% of the cluster management, especially with the latest release of Composer 2, which I'll talk about later on, to really kind of reduce your operational burden. I can't emphasize how important this stuff is. Right, a simplified architecture of Cloud Composer. Behind the scenes, Cloud Composer runs on a GKE cluster, and that's basically Kubernetes, right? So if you look at this diagram, it's quite interesting. So I kind of broke it down into some kind of really simple components that I think you should really know, right? There's a lot more to this thing, but I think these are the really key things you should know when you kind of delegate most of the operations to Google Cloud to run it for you, right? So first of all, if you look at the on the left, you can have one or more schedulers. So schedulers is one of those key component Airflow which Cloud Composer utilizes to run, right? So it schedules, right? It schedules the things we talked about earlier called DAGs, right? It triggers the DAGs, it schedules and it triggers the DAGs, and then the DAGs runs on the workers. So you can have one worker or a lot of workers, right? These basically utilizing the CPU and RAM resources that of the GKE cluster. And on the right hand side, when the operations runs, right, it also has to maintain some kind of states, right? Like say when the DAG got started, when the DAG got stuck, when the DAG got finished. So it uses Cloud SQL to manage the states of those DAGs. And that is important because it's otherwise, if you go away, you come back to the clusters, if something is broken, and it uses this to track if you need to do retries, how many times retries you need to do, and if it failed on anything, if this node goes away. So it has to kind of keep those states somewhere to be able to recover from it, right? And then to track where it got to. There are two other parts to it, right? So as a user, you typically do two things. First of all, you deploy your code to run on Airflow, right? And to subsequently run on Cloud Composer. So in the Cloud Composer way of deploying your code is you use the cloud storage bucket, which is another Google service. It's basically a distributed file system, right? You have your CI/CD pipeline, you push your code, and then you run it, you push it to a specific directory on the cloud storage bucket, right? And then behind the scenes, the composer cluster automatically syncs, right, the code between the cloud storage bucket and the workers, which are all of those those computers behind the scenes has the CPU and RAM to run your jobs, right? So that's how this whole thing kind of gets connected together from the code perspective. But the last thing you also do is Airflow has a user interface, right? That user interface gives you the ability to look at the DAGs, to manage the DAGs, to trigger the DAGs, to retry something and clear things up, rerun part of the DAGs. It's quite a powerful thing, right? So, and that's where the Airflow web server that runs in here, that you as a user, you access that, you can look at the DAGs and managing the operations. So that's pretty much in a nutshell the architecture of the composer cluster looks like. So the next thing, let's have a look at the web server and security. So the reason I want to talk about this is because this is one of these things that pretty difficult to manage if you do it yourself, especially on an environment where you have lots of users. You can actually tap into the web server itself to manage the DAG, which is a pretty critical operation, right? So you don't want to screw this up because this is the web UI that you need to manage. If you manage this yourself, you have to set up lots of different things to connect to the authentication services you've got. But with the composer cluster, this is one of the key issues it resolves, especially from a security perspective. So what it does is it uses, so you as a user, you connect to the Airflow web server not directly, right? You connect it via the Identity Aware Proxy, IAP. So I have another video talk about this. You can have a look at what it means and what you use it for. But in a nutshell, it's basically a proxy layer that knows who you are, right? Identity aware means it knows who you are as a user. Then if the user has been given certain roles to be able to access the composer cluster to see the web interface of Airflow, then you would be able to get in, right? So this uses the Google Workspace authentication, which subsequently can be connected to other SSO providers, right, such as Okta. So this is extremely powerful in the sense of you will use the SSO, the single sign-on that is hooked into Identity Aware Proxy to be able to access your web servers, and that subsequently really kind of protect your ability to access this, right, from the security perspective. So the command line tools is another very interesting thing and very, very useful as well. As you can see, so from the Airflow perspective, you can, if you're on the composer cluster itself, right? I'm saying kind of you're on the composer cluster itself means you have to kind of somehow SSH into the cluster. If you run it on a VM, you have to SSH into the VM. If you run it on a GKE cluster, you have to SSH into there somehow, right? So this is actually a very nice way that you don't have to do any of the things, and you can still have access to it that links to your user's identity using the gcloud SDK. So you can use the gcloud command to control the composer environment, and in addition, you can also do things like this, which is like triggering a DAG with a run ID. You can also list all of the DAGs and export it to a JSON format, right? This is actually very, very convenient in a way that you can actually interact with the DAG using the gcloud SDK, which would otherwise you have to kind of tap into a server and do that from behind the scenes. This is really, really useful. Right, Kubernetes Executor is one of these key features. I think I would have to emphasize this is really, really useful, right? And I'll explain it in a second and why this is the case. So if you remember earlier, just a couple of minutes ago, I talked about you sync your code with the cloud storage bucket, right? And then that gets synced into the workers which it runs your workload. But in actually a lot of scenarios, you can't actually do that. So that could be, let's say you want to run some Java workload, right? And then you don't have the correct Java version installed on your cluster. You want to run some Golang code, and then there's no Golang installed, right? And you have some custom Python packages. Actually, it has conflict with what you've got on the compiler cluster. These cannot happen. And then I can tell you for sure that one of the examples I encountered in the past was to run DBT, right? To run DBT core inside the composer cluster. That DBT stands for Data Build Tool. Is something developed by Fishtown Analytics is a very powerful tool that you can use for data transformations at scale, for example, on top of BigQuery. But those has, custom Python packages. It might not work with the packages already installed on the composer cluster. And how are you going to run these things? And that's going to be a bit of a nightmare, right? So this is where the Kubernetes Executor thing comes in. You typically create a Git repository, right? Not the same repository where you push your code to the compiler cluster, but just the independent repository that you would want to build your Docker image for that specific thing, right? Such as run your DBT workload. I also have another video on the channel talks exactly how to do that on the Composer 2 environment. So you basically build an image, right, through your kind of CI/CD process. Now you have the image pushed into GCR or Artifactory, and now you have a DAG created, right? This is quite interesting. You have your DAG created, then the scheduler will kick in to trigger those DAGs and subsequently trigger your code, which is actually inside a container, right? This runs on a kind of a specific area. You can see like it runs in Composer 1, it runs on a separate node pool, or you can run it on a separate node pool, but typically you can specify the CPU, the RAM, the auto scaling factors completely separate from your main Composer clusters settings, right? So this is something you can run quite separately. You can even say, I want to have, I don't know, like 500 gig of RAM to run some in-memory graph algorithm, right? And then that would probably take an hour to finish, and then you spin it up, run this thing, and then you turn it down, right? That's a use case it can be very powerful for in this kind of use cases. But the key thing is you can get around all of your issues, or if you need to install any custom binaries, that you can actually get around these issues that on the default Composer runners to use those the Kubernetes Executor Docker images, right? Right. So VPC native and private IP cluster. So this is something more related to security and also how to run your cluster in the right ways in order to connect or route your traffic to the on-prem network. So one of the most used use cases for the Composer cluster is because it's Airflow, right? So you want to typically connect to your on-prem network to get data out of it, right? You could have lots of databases in there that is well protected, and you need to have some kind of network such as the dedicated interconnect that Google provides or the cloud VPN to basically bridge the two together securely in a private network, right? And then you can actually access it. There's another thing that called the public cluster. So what that means on Cloud Composer is every single node, right, or machine on the composer cluster has a public IP, right? That's not a good thing to do. So even these IPs are firewall protected. They're not created for a very good reason. You don't need to have that many public IPs, in a cluster. And it also causes problems because you would end up in, let's say, you scaling the clusters. If you need 500 nodes, how are you going to scale it with 500 public IPs? It doesn't really make sense, right? And there's other issues with and when you need to give access, right, this is where you have you start talking about getting access to on the on-prem network. If you have public IPs, this is going to be a nightmare because the on-prem network is not going to open, access to the public, to some public IPs. That's quite risky, right? So instead, the VPC native private IP cluster, it has two attributes. The first thing is there is no public IP, right, whatsoever when you're creating your composer cluster. So you have primary ranges which are for your nodes, and you have secondary ranges which are for your pods. So these are just the illustrative ranges. You obviously work with your network team to make sure you agree on those ranges because there's no IP conflicts. But you typically can advertise these IP ranges to the on-prem network, which means they can whitelist you. And then when you come in, you can say, I want to get access to this database on this pod. They can say, I can give you a range to here, right? That's how it works. And so there is no public IP, right? Everything here is private. It's all routed privately. And one of the key features of the VPC native cluster, it can route all of your primary and secondary ranges via the pipe, either one of these, right, into your on-prem network. And that's extremely powerful because everything goes privately. There's no public access whatsoever. The other side of things is when you create clusters, there's an option to say, do you want to enable the public IP or not, right, for the control plane. This is where you tap into the Kubernetes clusters. You run like kubectl commands and they say list how many nodes I've got, how many pods I've got, what is the service status, and things like that, right? You don't want to have a public IP for those either, because that's a risk as well. If someone's got into that, it can be pretty nasty, right? So as an alternative, you should create this thing called the virtual machine, right? It's typically called a bastion host. So, and that is basically a machine sits on the same network as your Cloud Composer network, but the machine doesn't have a public IP either, right? This is really, really important. It's just a virtual machine that doesn't really have a public IP. But how do you get into the machine that doesn't have a public IP, let's say from your laptop, right? So again, that comes down to the identity aware proxy. So as a user using identity aware proxy, it knows who you are, and then you can use that on Google Cloud to connect to your VM, which is the bastion host, and then subsequently it will gain you access to the cluster itself after you got in, right? This is a very secure way to access this thing. So as you can see now, everything is private. There's nothing really you have a key floating around and then do the SSH, and it's not a good way to access your network, right? And this is a very secure way to run your systems and making sure you don't actually open this unnecessary risk to the public internet, right? And you probably would ask, right, oh, you don't have any public IPs, but how do if I need to have access to the internet, I'll have a SaaS product on the internet, and I need to somehow, access, APIs or get files from those environments. And that's where CloudNet comes in. CloudNet is, you can see it as a way, right? You can see this image is actually very nice. So you got there's multiple things coming in, right? And then this one thing goes out. And then what that means is you can have a lot of these IP ranges. You typically attach it to let's say a subnet, right? In this case, with a network or multiple subnets or on an entire VPC, right? And then you can say, it doesn't matter where the traffic is coming from, as long as it's connected to the CloudNet, I want those to be those IP specific, right, subnet IP ranges to have access to the internet, right? So this eliminates a number of problems, because if you, like I said earlier, if you have public IPs on every single machine, then there's a number of issues. One is very difficult to whitelist, because if you have just CloudNet, typically you have a couple of IPs, right? Some people just have one, you could have two or could have three, but typically you don't have that many. Then it really kind of depends on the outbound traffic, the number of connections you need to open at the same time, right? But in a nutshell, you just have a couple of IPs. and those couple of IPs are fixed IPs, right? It never changes. So you define it at the time you're creating a CloudNet service. And then this third-party the services can basically whitelist your IP, and this is outbound access only, right? There's only the way out, there's no way in, right? So that's what CloudNet is, and that is a very powerful way to not having a public IP cluster, but at the same time having a very easy way to manage IP whitelisting with other SaaS services on the internet. Okay. Composer 1 and Composer 2. This is where things got me really excited when kind of I started looking at the Composer 2, kind of started using our production. This is really important, because if you look at the differences from the left to right, and on the left is Composer 1 and on the right is Composer 2, right? So I'll go through this very quickly, but highlight some of the most important areas here. So first of all, in Composer 1, you have to manage your own node pool, right? So you create your Composer cluster, then if you need to have another node pool to run let's say the Kubernetes executor jobs, then you need to manage that yourself. And one of the most annoying things is when you create the Composer cluster, the size of the node, right? So let's say if it's I don't know, like 4 cores 4 cores 32 gig of RAM, right? Let's say that's what you created for. You cannot change the size of it, right? Or if you accidentally created with 2 nodes, with 2 cores and 16 gig of RAM, and then that is typically not enough to run a production cluster. It doesn't matter how many nodes you've got, right? And then it will, the scheduler will keep killing itself, and that's a huge problem. And then you realize, oh, your only option is to delete the cluster and recreate it again. Every time you kind of try to utilize this thing for different kind of workload, and then you realize you have to recreate this whole cluster again. That's just bonkers, right? So, and that's really one of the key issues for me in the past. And it does support Airflow 1 and 2. So I didn't mention the difference between the two earlier, but Airflow 1 has been around for quite a while, but Airflow 2 has gone to GA, I think it was last year. It has so much more features, and it's so much better than Airflow 1. So I'll probably mention a few key things. One of the key things for Google Cloud specifically, it has all of the operators, right? All of the operators on Airflow supports service account impersonation. And this is really key. Composer is a shared environment. You do not want to give Composer, the Composer service account, the cluster level service account, access to data, for example, right? So you want to give that Composer service account to just the bare minimum to operate the cluster itself. And then you use that service account to impersonate other service account that for specific use case. Let's say you need access to BigQuery on specific data set to run some projects, right? And then you only give that service account access to that, right? And then so this is something you configure at operator level to say, I want to impersonate this for this use case, the other ones for the other use case, and that gives you another level of security. So you don't actually, if you do have a breach, now someone have to figure out which service account it has to impersonate, which is not the easiest thing to do, right? Because it's all locked down. And by default, you don't have access to data, which is a very good thing to do. There are many other features like task groups, which you really help you to manage the task in a much better way, like in groups, rather than you just I think there used to be something called sub-DAGs, which didn't really work well. That was kind of scrapped. And then you have this task group, which is the new feature in Airflow 2 that is really working really well, right? There's many other features, but Airflow 2, is just so much better, especially on Google Cloud with the service account impersonation feature. And also in Composer 1, that you pay per node resources, right? Because you manage your node pool, you manage your node as well. So those nodes are visible on your virtual machine, like compute resources, right? So let's say if you have to create some large nodes, right? In that case, then you have to pay based on the size of the size of all these nodes. So that's actually quite a big difference, right? So if you may end up creating lots of nodes that you don't actually need it. So Composer 1 uses the normal GKE cluster, and the difference when we kind of move to Composer 2 is Composer 2 actually uses the autopilot cluster behind the scenes, right? That's what Composer 2 uses. And then the since I'm on that topic, if you look at the pay model, which I highlighted here, which is really important, is so the deployment model is based on the pod resources. So you don't actually pay for the number of node you've actually used, right? You pay the number of CPU and RAM you use. So this is a very big difference, because if you have auto scaling, which often you do, right? It goes up and down, and then if you stop using those resources, and then you just don't pay for them anymore, where you don't actually have to think about over provision the nodes to make the auto scaling, like manage that yourself. You just don't, right? You just pay based on the CPU and RAM you use, rather than the kind of managing at the node level, which gives you a lot more flexibility to kind of tailor your workload based on the pod level. So let's look at the Composer 2, right? So you've got the instead you have the GCP manage the nodes and node pool for you. And then the node size in this case is changeable after the class creation. This is one of the really big things I love, and because you can actually manage the node size for the cluster creation at the cluster creation time, and then you can change it afterwards. You can give it kind of the size, the minimum and maximum, all of that. I'll show you a screenshot of how that looks like, and it's really powerful. It does not support Airflow 1, right? So in Composer 2, but in my opinion, I don't know, unless I guess if you it's difficult for you to migrate from Airflow 1 to Airflow 2. You may want to kind of, that you probably don't have a choice to stay on Composer 1, but I really think you should try to migrate to Airflow 2, because it's been there for quite a long time, and majority of the features, the improvements have been done on Airflow 2. So you really kind of don't want to be left behind for that long, to be honest. So workload identity is something that's really clever. So Kubernetes has the concept of service account, and IAM have the concept of service account. This thing is actually clever enough, like you can use like a few simple commands to actually link the two together, right? So whatever role you give it to the IAM service account, then the workload identity side of things with the GKE service account is now aware of it, and then it will kind of inherit the same permissions, which means you don't need key anymore. This is very, very powerful. I think you can use it in Composer 1, but it's a manual. You have to manually enable it and then configure it yourself. So this is another one of these really good things. This is the screenshot I was saying earlier on, right? So you can see there's lots of things that you can define here. As I mentioned earlier, you don't control the nodes anymore. You can see there's no, how many nodes you need. It's all based on resources. So you can configure, how much resources you want for the CPU, memory, the number of schedulers you want, the web server resources, the worker resources, the scaling minimum, maximum, core infrastructure. So this custom is the one that you can tailor it completely to your use case. You could also use these presets if this works for you. But my point being, you can see this is completely flexible, and it's really kind of my lifesaver because of this thing, just this one thing. Right, at last, just a quick summary. In my opinion, you should really kind of get onto Airflow 2, right? So you don't want to wait for too long, and then when certain features gets deprecated in Airflow 1, so get onto Airflow 2 as quick as you can. Use Composer 2 if you can. There's one thing that doesn't support with the GPU, but I mean, for GPU use cases, you have many other options. You can even trigger a data flow job, right? You don't necessarily need to use GPU for that. You can also trigger a Vertex AI pipeline right from here. You don't need to run all that stuff on Composer. Always use the VPC native private cluster. Don't open anything to the internet. And this is really important, because not only allows you to route your traffic to your on-prem cluster easily, but also keep your environment secure, right? So at last, always use CloudNet for outbound internet access, because this gives you fixed IPs and not a lot of them, so you can easily whitelist, and it's much safer as well than giving, using a public cluster, giving all of these public IPs, which is not great. Okay, all right. Lots of information. So yeah, so hopefully that was useful to give you a kind of tour of Composer and Composer 2 and Airflow, a little bit Airflow. Yeah, that's the end of the session. I'll see you next time. Thank you. Bye.
Go.